Hello guys, I'm Christian, you know me, and today we are going to be talking about chapter 5.1 and 5.2. So, we start off with polygons. Polygons are a closed plane figure formed from three or more intersecting segments. A vertex, a point where the edges of a figure meet. Diagonal of a polygon, a segment that joins two non-adjacent vertices of a polygon, such as these. So we'll move on to a better example. So we have the interior. We will be discussing the interior, the exterior angles, and we will also be discussing how to find the triangle region and what a triangle region is. Okay, so I will move over to SketchUp 8. So right now we will be discussing what is a triangle region. Well, a triangle region is the minimal amount of space, the, the a diagonal that separates areas of a triangle, of a polygon, into the most into the into the amount of diagonals that it can have without having overlapping diagonals. So, for example, since this is a triangle, it has one triangle region, as we can see. It cannot have any diagonals. I can try. No diagonals here. So we move on to here. And we have a square which has two diagonals technically, but we have one already drawn because these are the two triangle regions. So the question was, what is a triangle region? Well, a triangle region, triangles are the basis off of which this whole area, all polygons seem to be based. Because you can split any polygon, regular polygon, any polygon, into a triangle. So triangles are the basis. So I can separate this again, but since these lines are intersecting, that does not work. So these triangles, we know that triangles are 180. So this triangle right here, if we were to take all these interior angles right here, these ones, yeah, these ones right here, we would have 180. But we already know this because we've learned this. So the reason triangle regions are very good are for the fact that it makes finding the angles easier. So I can put these in here. So we have these ones in here. So we have 90. So we'll even this out. Okay, so these ones are 90. We know this. So, and we know each triangle region is 180. So we know that this whole thing is 360. The interior angles. So this makes this 90 by that, and that makes that 90. So therefore, a square is equal to 360, while a triangle is equal to 180. Are you kind of starting to see a pattern? Well, you should. So we'll move on to a pentagon. So we know that this is 180, this is 180, and this is 180. So therefore, we have 540 degrees. This angle plus this angle plus this angle plus this angle plus this angle are going to equal 540 degrees, because you add this triangle plus this triangle plus this triangle, and that shall equal 540 degrees. So we're going to go to our equation where alternate interior, where these will work out. Let's say that. Yeah. So we'll find out what the actual equation to, if you were to input it into a calculator per se. So we're going to go here to this, and this may seem confusing, but this is what we need to worry about. This is the interior angles, the sum of the interior angles. So we have S as our sum. So we have S again here. And then we use that 180 because that is a triangle, as we remember. And then we think, how many sections? We have 3 triangle sections. So, and we normally have 5 sides. So, and then we have the same issue here. We have 4 sides and 2 triangle sections. 3 sides and 1. And so on. So we go back to this drawing, and we have this, which is 180 in parentheses n minus 2 equals the sum of all the interior angles. So we found this because of that, and when we have that, we can know how much an individual angle is. Because if I wanted to know what this angle is right here, I know what this angle is right now because I found it already. But if I wanted to know and I only knew the sum of what a quadrilateral sum is, which is 360 degrees, we have to find out what this angle is. How do we know what that angle is? Well, we know it's 90 per se. So let's take that and input it into an equation. So, for example, we'll go here. Let's do triangles. You take the number of sides, you take the total sum angle, and then you divide by the number of sides. Does this make sense? Because if I were to have this right here, say these are all 90 because it's a regular polygon, meaning it's equilateral or equal. So all these angles are equal. So therefore, or in some form, this works for normal polygons and regular polygons. So all these are 90. So if we do 90, 90, 90, 90, that equals 360. So that's how you find. So our equation is going to be the sum, which is 180 parentheses n minus 2 divided by n, sorry, where n is the number of sides. So if you take this sum divided by the number of sides, you have a number that is capable of finding the individual number. So we shall move on to the exterior. So I happen to have a protractor on this, so it makes it easier. But so we will use this and we'll find a degree. So this says that it's about 45 degrees. So this is a little off, but it is close enough that it isn't that far off. So these are about 45 degrees each. So we're looking at 90 degrees. So if I want to find this, I need to subtract what this angle is. So since this is 45, I need to go over here, making this 135, approximately 135 degrees. So, this needs to equal 135 right here. This angle. So this angle right here. So that angle is equal to 135 degrees. So I'll make that into an angle. So let me make this into an angle. Then we can move on. So this must equal 180 degrees, which it does. So therefore, since this is, let's make this a triangle. So we have this, which is a big number. Since this is 45, this is 90. So we have to take, so we pull up a calculator. It is 135 times 2, because we add this one up here, times 2. And then since this is 90 degrees right here, we add 90. So we find that this is 360. We find the same thing to be true when we do other angles. For example, a square is 90, 90, 90, 90, as we know. So we do 90 times 4 is 360. For it to be, you have to find the exterior. You need to find the other 90, so it equals 360. Well, a regular pentagon will be 72 degrees. So we can multiply that by the number of sides, which will equal 360. So therefore, all exterior angles shall equal 360. Well, this has been a very good time, and we have many more times to cover, but we shall discuss these in a bit. With the sum of the exterior, just 360, as we have discussed. We have gone over the interior, which is the 180 times n minus 2. So remember that the sum of the interior is 180 times n minus 2, while the one interior angle is 180 times n minus 2 divided by n. And don't forget your triangle regions. If you remember your triangle regions, you'll remember everything. So remember that to find your triangle regions, it's the number of sides, n, minus 2, because number of sides, triangle regions right there. That is the number of triangle regions. So we will continue with our PowerPoint, and then we shall